polynomials, without having to graph it, we can describe what's going to happen on the right side and the left side of our graph. So we can describe the end behavior for every polynomial. So our first example up here, what we want to look for, first make sure we're in standard form. Our exponents are in descending order, so we're okay. And we are going to take our leading term, this 4x squared. We're going to be able to tell everything from that one term. Now over here we have some notation that looks a little bit different than what we're used to seeing. So when we see this f of x right here, that's like saying, what is the graph doing? So is the graph, what's going to happen? Is it going to, pretty much we're trying to figure out, is it going to go up or down? So, well, I'll talk about that in a second. And then as x approaches positive infinity. Now if x is approaching positive infinity, that is the right side of our graph. Here's where our x's keep getting bigger and bigger and bigger, heading out that way. So we want to know what's happening on the right side of our graph. And what we do is we look at our leading coefficient, this 4, and say, okay, is the 4 positive or negative? Because that's a positive 4, that tells us that on the right side of our graph is going to be going up. Positive means it's going up. Now, we have to be, use the correct notation. If we're going up, is that approaching a positive infinity or a negative infinity? Going up is a positive infinity, so we're going to put a positive infinity right there. Now this next part, what is the graph doing? Oops, that's f of x. As x approaches, now it's a negative infinity. Negative infinity is saying, okay, on the left side, as you're heading out as your x's get more and more negative, out to negative infinity, is your graph going up or down? And here's what we look for that is your degree, the exponent in your leading term. We want to figure out if that's even or odd. Since this 2 is even, that means it's going to do the same thing that the right side does. Since the right side went up, that means the left side is going to go up too. As it's going up, it is approaching a positive infinity, so that's what we fill in over here. Now with our graph, we don't know what's happening in here. We could have some crazy stuff like that, but we're able to describe the end behaviors. We know it's going to be approaching a positive infinity on both sides. So here's another example. Again, in standard form, we're paying attention to our leading term, 2x cubed. I look over here at the notation. We're figuring out, okay, here's what's the graph doing. As x approaches positive infinity, this is the right side. And to determine that, we look at our leading term. 2 is positive, so that means that our graph, if I were drawing it, it would be going up on the right side. Now going up means it's approaching positive infinity. Now as x approaches a negative infinity, that's the left side. We look at our degree. Now in the last degree it was even. This one is odd. If our degree is odd, it's going to do the opposite of what the right side does. Now remember, those are your O's. The odd goes the opposite way. Since the right side was going up, our left side is now going to head down like this. Probably some crazy things, we don't know what's happening in here. But we know what's going to happen on the end. So since it is going down like that, that means our graph is approaching a negative infinity. Those y values keep getting negative, more negative. So there are 2 examples for describing the end behavior. I will do another 2 examples where the right side is not going up. So check those out, please.